Before watching the video, don't forget to subscribe to our channel by clicking the subscribe button below and clicking the bell icon to be notified whenever we publish a new video.
Born in 1642, the English physicist and philosopher Sir Isaac Newton revolutionized the world's understanding of the physical universe with his three laws of motion. Newton's first law of motion states that all objects continue in a state of rest or uniform speed in a straight line unless acted upon by a non-zero net force. In other words, an object at rest tends to stay at rest, and an object in motion tends to stay in motion, unless acted upon by an outside force. This law can be observed when a tablecloth is whipped from underneath a dinner setting while the dishes remain in place. Because the dishes were initially at rest, they will continue in their state of rest. Likewise, when a fast-moving subway car comes to a quick stop, passengers inside continue traveling at the previous uniform speed of the car and get thrown forward. This property of matter to remain at rest or in motion is known as inertia. Newton's first law is often termed the law of inertia. Newton's second law states that the acceleration produced by a net force on an object is directly proportional to the net force, is in the same direction as the net force, and is inversely proportional to the mass of the object. This basically means that it takes a greater force to move or accelerate objects with greater mass than it does objects with lesser mass. Mathematically stated, a moving object's acceleration equals the net force acting upon the object divided by the mass of the object, or A equals F divided by m, where acceleration is measured in meters per second squared, force is measured in newtons, and mass is measured in kilograms. This equation dictates that acceleration is directly proportional to force and inversely proportional to mass. When force increases, acceleration increases. And when mass increases, acceleration decreases. Take, for instance, a scenario where you're pushing a 10-kilogram box along the ground with a force of 20 newtons. The acceleration of the box equals the force you exert, divided by the mass of the box, or 2 meters per second squared. If you push 10 newtons harder, the acceleration of the box will increase in direct proportion and becomes 3 meters per second squared. If the mass of the box is increased to 20, but the force stays the same, the acceleration will decrease in inverse proportion to 1 meter per second squared. Newton's third law of motion states that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. In other words, when one object pushes against another, the force applied by the first object is opposed by the force of the second object that is equal in magnitude but in the opposite direction. For every action, there is an equal and opposite reaction. These equal but opposite action-reaction pairs define force in the physical world. When you exert a force against a wall, the wall pushes back with an equal force but in the opposite direction. When you take a step and push your foot down against the floor exerts a force back up to your foot. Every action of force has an equal but opposite reaction.
Thanks for watching. If you like the video, give it a thumbs up and share it with your friends. For more tutorial and tips, subscribe the channel.